We're going to take a moment now and pause with the hypothesis testing and go back to chapter 4 and remind ourselves about contingency tables. We saw a little bit of contingency tables when we were dealing with some probabilities, but we want to expand our knowledge of that. So a contingency table is when you have two variables that are cross-listed with each other. So one qualitative variable and another qualitative variable. So for example, in this particular example, we have the type of history course the students are taking and then their ethnicity over here. So you have two directions. You have the columns and then you have the rows, right? So there's the rows, there's the columns. Okay, so a history professor teaches 3 types of history courses: American history, world history, and European history. The professor would like to assess whether student preference for these courses differs among 4 different ethnic groups. Okay, so when you look at this, you can see in chapter 4, we were asking questions like, what's the probability that a student chose out American history? What's the probability of being African American, etc., from this group? So we have the two directions. The column variable would be up here. It's the type of history course. And the row variable would be the ethnicity. So those are those two. And each little box is called a cell. So when you want to know how many African Americans were taking European history, that would be African Americans, and you go to the European history group, and it's right here. There's the European history. All right, so those are the basics that we learned back in chapter 4. Now we're going to kind of expand upon this a little bit, and we're going to learn how to find something called the marginal distribution, which we actually did find in chapter 4 to be able to find probabilities. It's when you want to find the totals for the columns and the rows, right? So columns down here, rows over here, and you want to add them up and find out how many there are in each group. This will be a marginal frequency. Frequency means I'm just going to add. So I'm going to take 100 and 40 and 60, and together that all makes 200. Then I take 100, 40, and 20, and that would make 160. And then 140, and then 100. And when I total this, 200, 160, 140, and 100, I get 600 total. All right, now the columns, 100, 150, and 50 would make 300. And then this would make 160. And this would make 80, 60, 140. And if I do it right, then these 3 numbers and these 4 numbers should all add up to the same grand total of 600. So the total of the row totals and the total of the, well, these are the column totals, sorry, and the total of the row totals should all make the same grand total of 600. So we used this back in chapter 4 because I would say, what's the probability of being African American? And we would say 160 divided by 600. What's the probability of being in the American history class? That'd be 300 divided by 600, that kind of thing. All right, now we're going to expand that idea and we're going to find the marginal relative frequency. So the relative frequency means you're going to find out how frequent was that group in relation to the whole. So for example, the Caucasian relative frequency would be 200 divided by 600. And that would give me my relative frequency in that group. There we have it. And then for the next group, it would be 160 divided by 600, and then 140 divided by 600, and then 100 divided by 600. So let me type those up 1 second. All right, so there are all those values filled in right there. Oops. Okay, so now we also want to do it down here for the columns. So we want to take each of these columns and think, okay, this makes 300. 300 divided by 600 would be a half. So that would be that particular one. So 300 over 600 makes 0.5. And then we do it again for the next group and the next group. So it'd be 160 over 600 and then 140 over 600, which is convenient because those are the same totals for some of the rows. So that's all done. And the last one would actually be, if you did it right, 600 over 600, which makes 1. So if you add up these 4 fractions, you should get 600 over 600. If you add up these 3 fractions, you should get 600 over 600. All right, so now that we've found out how to make both a marginal frequency, those are whole numbers, and a marginal relative frequency, those are the decimals in the total for the rows or the columns, we want to answer just a couple questions. How many people were taking American history all together? All right, so American history would be this column right here, but they want to know how many people total that was. So I want to look at the the marginal frequency and see that that was 300 right here. Okay. How many Hispanics were in the sample altogether? So in the sample altogether, there were 100 Hispanic students. There they are right there. So that would be 100. You know what, I'm going to highlight those just so we can see them real quick. So the 300 comes from this 300 right here, and the 100 right here gives us this 100 right there. All right, so these were both how many questions. How many questions you would answer with the regular marginal frequency. All right, now the relative frequency will answer what percent or what probability. So what percent of the students were in world history? So world history is this column right here, 26.6% or 26.7% were in that class. There we go. And I get that from this part right here. So it's 26.6 repeating percent. All right, what is the probability of randomly selecting a Caucasian student? Well, a Caucasian student would be, let's see, right here at the top, right there. So that'd be 0.3 repeating. So that would be 33.3%. And then instead of a 6, we'd have a 3%. Like that. And that would be coming from this number right here. That's where that's coming from. All right, so we're all done with reviewing the basics of a contingency table and then finding the marginal frequency and the marginal relative frequency and using them both to answer questions. This question in particular is the kind of question that we answered in chapter 4 long time ago. All right, I'll meet you back here to talk about conditional distributions in the next